Hello, everyone. Today we are going to talk about simplifying radicals. Simplifying radicals is a really important topic because you're going to use this for all future mathematics. So the product property of square roots. The product property of square roots and prime factorization can be used to simplify expressions involving irrational square roots. When you simplify radical expressions with variables, use absolute value to ensure non-negative results. So for any numbers a and b, where a is greater than or equal to 0 and b is greater than or equal to 0, square root of ab is equal to square root of a times square root of b. So what we want to do is we want to look at 180 and we want to find its factors. And we're looking for perfect square factors. So 180 can be simplified as 90 times 2. But neither one of those are a perfect square. I can do 45 times 4. 45 is a perfect, or 4 is a perfect square, but I want to simplify that more. So the best thing to do is to do a factor tree. And when I do my factors tree, 180 is 90 and 2. 2 is simplified. 90 is 45 and 2. 2 is simplified. 45 is 9 and 5. 5 is simplified. And 9 is 3 and 3. So the prime factorization of 180 is 3 times 3 times 2 times 2 times 5. Now notice I wrote my pairs at the beginning because the square root of 3 times 3 is 3. And the square root of 2 times 2 is 2. And then I have square root of 5 left. So the answer is 6 radical 5. Now I could have done that without doing the factor tree. The method without doing the factor tree requires me to find the biggest perfect square. So the biggest perfect square in 180 is 36. 180 is 36 times 5. So I broke up 180 into 36 times 5, and the square root of 36 is 6. So that is 6 square root of 5. So now, for example 2, and do the same thing with 120. So when I do the same thing with 120, I like to do my perfect squares. So 120 is 4 times 30, and 4 is the largest perfect square factor. So I'm going to break this up into perfect squares and non-perfect squares. So 4 and 30. Now a squared is a perfect square because even powers of variables are perfect squares. So a squared is a perfect square. B to the 5th, that is not an even power, but I can break b to the 5th into b to the 4th and b. All non-even powers I want to break into an even power and 1. Because remember, when we multiply exponents, we add. See, the 4th is even. So now the square root of 4 is 2. On my variables, I divide the exponent by 2. So a squared is a, b to the 4th is b squared, c to the 4th is c squared, radical 30b. So let's try some more examples. So I want you to pause and try 1 and 2. Okay, so for number 1, 28 is 4 times 7, so I made that radical 4 times radical 7. Square root of 4 is 2, so it's 2 radical 7. The square root symbol only goes away when you take the square root. 68 is 4 times 17, so it's radical 4 times radical 17. Took square root of 4, which is 2, so it's 2 radical 17. Number 3, we have a 2 out in front. So I bring the 2 over here. I'm going to break radical 60 into radical 4 and radical 15. Square root of 4 is 2, so that's 2 times 2, radical 15. And I can multiply the 2 and 2 because they're on the outside. So that's 4 radical 15. So I want you to pause and try 4 and 5. Okay, so number 4, square root of 75 can be broken up into the square root of 25, square root of 3. Square root of 25 is 5. Multiply 2/5 by 5, and I get 2 radical 3. Number 5, square root of 182 can be broken up into the square root of 81, square root of 2. Square root of 81 is 9, so 9 radical 2. Now when I have multiplication, I can multiply everything on the inside by other things on the inside, everything on the outside by other things on the outside. So since 3 and 6 are still both under the radical, that equals radical 18. I now need to look at 18. Does 18 have any perfect square factors? And it does. 9. So it's radical 9 times radical 2. So my final answer is 3 radical 2. It is really important for this unit that you know your perfect squares. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. You should know at least those. So here, radical 2 times radical 5 is radical 10. 10 doesn't have any perfect square factors. 8, radical 5 times radical 10 is radical 50. 50 has a factor of 25, so that's square root of 25. Square root of 2, square root of 25 is 5, so it's 5 radical 2. I want you to pause, and I want you to try the next. Let's try the rest of them and come back. Okay, so on number 9, it's square root of 4a squared. Square root of 4 is 2. Square root of a squared is a. Then negative 3 times 2 is negative 6a. 10 is 2/3 times square root of 9x to the 4th. Square root of 9 is 3. Square root of x to the 4th is x squared. So then 2/3 times 3 is 2, so it's 2x squared. Square root of 300a to the 4th. 300 can be broken into 100 and 3. 100 is a perfect square, so the square root of 100 is 10. Square root of a to the 4th is a squared, and then radical 3, because the 3 did not have square root taken. Number 12, 128, can be broken up into 64 and 2. 64 is a perfect square, so it's square root of 64 is 8. Square root of c to the 6 is c cubed, so it's 7/8 times 8c cubed is 7c cubed, radical 2, because I did not take square root of 2. 24 can be broken into 4 and 6, and then square root of 4 is 2. Square root of a to the 4th is a squared. Square root of b squared is b. And then radical 6. Square root of 81 is 9. Square root of x to the 4th is x squared. Square root of y squared is y. 150 can be broken into 25 and 6. A and b both have even exponents. C does not, has an exponent of 1, so that I can't take square root. Square root of 5 is 5. 25 is 5, square root of a squared is a, b squared is b, radical 6c, because those I could not take square root of. Then here, 72 I can break into 36 and 2. A to the 6 is even, b cubed is odd, so it's b squared and b, c squared. Square root of 36 is 6, square root of a to the 6 is a cubed, square root of b squared is b, square root of c squared is c, then radical 2b, because I did not take square root of those. 45 can be broken into 9 and 5. X squared is even. Y the 5th is odd, so that's y the 4th and y. I always break it into even and 1. Z the 8th. Square root of 9 is 3. Square root of x squared is x. Square root of the y to the 4th is y squared. Square root of z the 8th is d the 4th. Radical 5y, because I did not take square root of those. 98 can be broken into 49 and 2. The exponents are all even, so the square root of 49 is 7. X squared, y cubed, z squared, square root of 2. If you have any questions, please bring these to class.